Welcome to the next episode of the Multiplayer Inventory System series. Today we'll complete the storage box functionality. As seen in the preview, two clients and one server can simultaneously interact with the storage boxes. Let's dive in. We begin by opening the character blueprint and navigating to the input mapping graph. On the left side, we'll set up the logic. Start by creating a new custom event named Interact Server. Set its replicates property to run on server to ensure that interactions are processed correctly on the server. Next, we create a function named trace for interact. This function will handle the sphere trace logic for detecting actors the player can interact with. First, drag the follow camera into the graph as a get node. Search for and add the get world rotation and get world location nodes for the follow camera. These nodes will determine the trace's starting position and direction. To adjust the trace's start point for a better player experience, add an add vector node to the get world location output. Here, increase the Z value by 50. This adjustment compensates for the slightly lower camera position in the game, enabling more intuitive aiming, especially without a crosshair. With the starting setup in place, connect the execution pin of the function to a sphere trace by channel node. The sphere trace by channel is a powerful tool for detecting collisions along a path using a sphere of a specified radius. It checks between a start and end point, interacting with objects on the selected collision channel. The node is ideal for identifying obstacles, surfaces, or nearby objects. It also returns critical hit details, such as the location and the actor hit. Now, connect the calculated vector from the add node to the start pin of the sphere trace by channel node. Next, take the pin from the get world rotation node and search for the get forward vector node. Use the return value from this node and add a multiply node. Right-click on the vector pin of the multiply node and change it to a float pin. Enter the value 800, which determines how far our trace will go. Add this calculated vector to the start vector, and then connect the result to the end pin of the sphere trace. Let's organize everything neatly. You know me, I emphasize keeping everything well arranged and visible, so we can better follow along and avoid creating spaghetti blueprints. Now drag out the actors to ignore pin from the sphere trace node and select Make Array. In index 0 of the array, connect the self-reference. This ensures that the trace ignores our character and passes through them to search for other actors. Set the radius to 10. Change the draw debug type to for duration so we can visually see how our trace is executed. Take the execution pin from the sphere trace by channel node and add a branch node. Next, drag out the out hit pin and create a break hit result node. Expand this node and pull out the hit actor pin. Search for the does object implement interface node. And for the interface, select BPI interact. This will check if the hit actor has the specified interface implemented. Now, pull the return value pin from the sphere trace by channel node and add an AND operator node. Connect the return value from the interface check to the second input of the AND node. Link the output of the AND node to the condition pin of the branch. If the hit actor does implement the BPI interact interface, connect the true execution pin of the branch to a call function node for the interact interface on the hit actor. Go back to the input mapping graph and connect the newly created trace for interact function to the execution pin of the interact server event. Next, we need an input action. Navigate to the content, third person, input, actions folder, and duplicate the IA_UI_inventory action. Rename the duplicate to IA_interact. Then, go to the input folder and open IMC_default. Click the plus sign to add a new input action and select IA_interact, assigning it to the F key. Save your changes and return to the blueprint. Search for IA_interact as an enhanced action event. Expand it, take the started execution pin and connect it to the interact server event. Arrange the nodes neatly and add a comment, labeling it Interact with Actors. Find a comfortable spot for this setup, perhaps to the left for better organization. Before testing the setup, let's revisit the Trace for Interact function. I forgot to set the self-reference for the character ref pin in the Interact interface function. Without this, the actor won't know which character is attempting to interact. Now, press play and test the functionality. When you press F near the storage, the widget opens. However, the storage inventory appears empty without any slots. Don't worry, exit the play mode and go to the storage box blueprint. Select the storage inventory component and, in the details panel, specify the number of slots the storage should have. Let's set it to 30 slots for now. So let's press play, give ourselves a few items, and approach the first storage box. When we open it, we see that the box now has 30 slots. We can transfer items from our inventory into the box. Closing this, we move to the second box, where we transfer some meth and a couple of pumpkins into it. After closing it, we move to the third box and transfer a hammer and another pumpkin, and one more pumpkin into the hotbar. Closing it, we head back to the first box and we can see the items we left there earlier. We move a few items around, close the first box, return to the second box, and confirm that the items are still present. As you can see, the inventory system works as intended. The boxes save their contents, and everything functions beautifully. However, upon exiting the play session, we notice an unsightly error message. Let's address it in the next steps. Click on the Remove from Parent error to jump directly to the problematic location in the blueprint. As discussed in the previous video, the issue lies in the for each loop. Take the mappings pin from the IMC target and search for each loop with break. Hold the Control key while dragging the connections from the old for each loop node to the new one. Delete the old node and position the new for each loop with break in its place. Next, zoom out for a better overview and locate the execution pin of the Change Mouse Mode UI node near the end of the event. Connect this pin to the break input of the for each loop with break. This ensures that when the widget is closed, the loop breaks immediately, preventing any further key checks. Now, switch the game mode to play as Listen Server and set the number of players to 3. On the left side, you'll see Client 1 and Client 2, while Server 0 appears on the right. Using Client 2, approach the storage with some items in your inventory and open it. Move the hammer into the storage. Then, switch to Client 1, open the same storage, and add items. You'll notice the updates are synchronized across both clients. Finally, as the Server 0, access the storage and rearrange items, observing that all changes are reflected on both clients. Spend a moment experimenting, move items back and forth, and you'll see that everything runs seamlessly. With that, the part focusing on the storage box is complete for now. Feel free to experiment further, and if you come across any bugs, let me know in the comments so I can address them. If there are additional features you'd like to see, don't hesitate to share your suggestions. Next, we'll either implement an inventory weight system or create a sorting mechanism for items. Let me know which feature you'd prefer to see first, and I'll prioritize it. A huge thank you to everyone following my channel. I didn't expect to gain so many viewers so quickly, and it's both exciting and motivating to continue creating tutorials to help you progress with your dream projects. With that said, enjoy developing your game, and I'll see you soon.